So I think, yeah, everybody's here. Welcome to this brief workshop. I mean, it's not that brief, but to this workshop, the Smart Collaborative Agents. My name is Diego Pinochet. I am a PhD student at the Design and Computation group here at MIT. I am also a professor at the Design Lab School of Design of Adolfo Ibáñez University in Chile. This is a school that was founded by alumni of the Design and Computation group at MIT. And yeah, I've been working there since the last 8 years with some interruptions because in the middle, I came to MIT the first time for my master's, and then I went back to Chile, and now I'm here again for about 2 years. So I will introduce myself, and hopefully then we will do a brief introduction of everybody so we can get to know each other. So I am from Chile. For the ones who don't know, is the longest country from north to south, and basically it's so long that we have almost every type of climate. So for example, we have the driest desert in the world. We have, like, of course, polluted cities like the one that you see in the bottom right of your screen. And we have also in the south of Chile, amazing forests and Patagonia and glaciers and volcanoes and lakes and rivers and so on and so forth. It's a very special country. We're in the bottom of South America. And basically, I am an architect. I was trained as an architect. I studied in the Pontifical Catholic University of Chile, one of the major architecture schools. I started my own practice in 2007, where I was able to design and build some buildings. I call myself what is called a one-hit wonder architect. This building won the Art Daily Building of the Year 2009 in architecture, in institutional category. And I've been since then doing like some, for example, like residential projects, and always trying to combine computational design, parametric design, and sound simulation, especially like using building information modeling to basically combine both activities. Also, I did like some interior projects and other projects. For example, that huge head that was really interesting as a fabrication process that was for Lollapalooza, Chile in 2016. Also, I've been in academia for 11 years now. I started teaching in 2009 in many universities. And as I was saying, since 2012, I've been part of the design school at UAI University. But in 2013, I came to MIT for the first time. And that was really great because that somehow shifted my research or my interest. I was really into BIM and like construction and fabrication for the building industry, basically. But I got really interested in robotics and also in AI, mostly like the theory of AI and cybernetics. And for my research, when I did my second master's degree, I have a previous master's degree also in architecture that I got in 2008. I got my second master's degree at the Design and Computation group, the same group where I am right now, where I developed this interest in, especially in interactive fabrication. So I developed for my thesis this proof of concept. My thesis was half theoretical and half applied, where I developed this machine that was embedded with machine learning to do like classification predictions about movements of people and also modifying trajectories so you could teach a machine to follow your movements and your gestures and also do like several type of things. It was like a fun thesis, like a lot of work. This one also an award in Japan. And since then I've been, when I returned to Chile, I've been working with different people, collaborating. This is a collaboration with Jose Sanchez from Plethora Project, the guy that makes video game and super popular because of the processing tutorials that probably everybody has seen. So we did like a discrete system based on like this unique wooden member and this super sophisticated metal joints. So you can build like structures like really easy with, I don't know, like among two people, between two people. And also in the past few years, I've been working with other type of projects also related to what is my main interest. I'm really interested in the process of like from idea to physical object and everything that happens between like in the design and making process, right? So this project was really interesting where we were advised by also like people from Google here in Cambridge. I worked with a colleague from the building technology department, and we did this this project that is called Skexo, where we were training different like deep neural nets and 3D GANs in order to translate instant sketches to 3D objects. It was a really interesting project in which basically we were training 3D GANs to create like any type of voxel-based 3D objects according to what a person will sketch on an iPad, for example. So it's like really fun, and basically this continued my interest in what I was saying, this transition between something that is an idea or basically like a basic sketch to something that is like more definitive. In the past year and a half, I'm showing you this so I can give you a little bit of background. And of course, this is not, the videos are not working, but I will show it to you immediately. I've been working in I think this is the one. Let me get out of this presentation for a bit and show you, yeah, maybe here. Can you see the video? Yes?
Yes.
I've been working also, I work currently as a researcher at the Encoded Elements Lab here at MIT. It's run by Marcelo Coelho, a designer, PhD from the Media Lab and current head of design at Formlabs, the 3D printing company. And we are developing tools for Philips, the electronics company, and they have a division that is Signify. And we are working with them developing this sort of grasshopper for light designers. Where I've been coding and developing this node-based tool to use machine learning also to design light behaviors. So it has been like really, really interesting. Finally, and I will try to be very brief before we get to the next part where I will show you other things. I hope this works now. I've been also working in, I don't know what's going on with, I hate Google Drive also. Let me show you this video. I've been working extensively with, with robotics and also the idea of like this real-time interaction with robots. So this is a project that I developed last year where I was basically controlling and generating code for KUKA robots in real time based on my hand gestures. So as you see here, I was in an application made in Unity using, for example, a leap motion, or it could be a Kinect. I was controlling and calculating on the fly the inverse kinematics, and that will give me the result of this KRL code for KUKA. At the same time, the other things that I've been doing, if I can show you this, hopefully it will work. If not, I will show you the video. Again, of course not. You didn't see that yet. I've been working, these are projects from classes, for example. Another thing that is related to the past video that I showed you with this real-time interaction is how can you, for example, give deep perception to robots, and how, for example, from the feed that you get from, I don't know, like a point cloud sensor, like a Kinect or like Intel camera, can you basically discriminate objects and filter point clouds to detect objects in a point cloud instead just like a 2D image. So this was like a really interesting project. This is like probably a bad video. I didn't have time to put another one, but what you see here is that you are detecting an object and you're filtering according to the detection all the points in that basically huge amount of information that you're getting from your sensors. So this is really nice because you can get a really clean point cloud of an object, and also you can calculate or extract the rigid transform of an object, that is the position and also the rotation. So for example, you can make a robot to go and grab an object in real space. So this basically shows part of my interest in this interactive robotic manipulation that I've been working in the past, let's say, I don't know, 5 to 6 years. And I still don't know what I'm going to do for my PhD. I'm finishing writing my general. My PhD is a 5-year program. So hopefully I have to decide what will be my specific PhD subject. So now it's your turn to present. I mean, I think this is enough information about me. I just wanted to give you, as I said, a little bit of context, and it will be nice if you can introduce yourself so everybody get to know you. And if you can also turn on your camera so we can see you, that will be also really great. So who wants to start?
I can start.
Okay, good.
Okay, great. So I'm Ardavan Bitgoli. I'm a PhD candidate at School of Architecture at Carnegie Mellon University. And I see a couple of friends here also. My field of research is basically on the intersection of machine learning and creative activities. And my focus is on tool making apparatus for creative users. In that case, I'm using generative models to learn and generate new activities, new actions for creative users in activities like choreography, painting, and tasks that require hand dexterity. And my experience with Unity and the other tools that you have here is like, regarding Unity, it's just a little bit. Regarding machine learning, a little bit more. I have co-authored a paper with Pedro Veloso, who is here, on generative models for point cloud objects, and recently published a paper in the Roman conference about the way we can use robotics for painting using machine learning. I think I'm just trying to keep it concise, so there will be time for other people here.
Thank you. Who else?
I can go.
Okay, Eric.
Ardavan mentioned me, so okay.
Just real quick. My name is Eric.
Eric.
I live in Texas. I'm from Mexico, and right now I am a graduate research assistant in the robotics laboratory. And basically, what I really do is just kind of try to research and find new ways to use different types of end effectors for robotic fabrication, and basically developing new toolpaths and new behaviors for those robots. We have KUKAs, and so that's kind of where I'm looking to apply whatever I learned from this course into.
crossing fingers, you will learn something. Okay, who else? What about, do I have to name it or? Okay.
Yeah. Hi all. I'm Pallavi Rai. I'm from India. So I'm an architect and also a product designer. So what I'm interested is towards what the future of design would be with all the emerging technologies, and also how the role of the designer would change with, you know, automation coming into various parts of the design process. So yeah, that's what I'm looking towards.
Awesome. Who else?
I can go.
Mm-hmm.
Hello, I'm Chen Hua. I'm currently living in Vienna. I just finished my master thesis last week. It's mainly working on Unity with Grasshopper to like constructing like scan random geometry and working on how to assemble them with consideration of how to assemble different joints with different geometry. And mainly use reinforcement learning as like creating a assembly game for the Unity to like play with it and try to assemble into an architectural form. Yeah, that's a simple way.
Good.
I can go.
Mm-hmm.
I'm Chris. I'm a recent graduate, currently living in New York. I'm working here for a couple of years, and I'm starting my master's at the Bartlett in September.
Hello, guys.
Hello. Do you want to introduce yourself?
Yeah, my name is Dhruv. I am from India, but right now I'm working in UK in an interactive art studio, I guess, something like that.
Good. I see. Let's see. Gianluca.
Yes. Hi, everybody. I'm Gianluca. I come from Italy, and I'm a student in engineering and architecture in Bologna. And at the moment, I'm working on my research thesis based on agent systems. And so I'm learning to use scripting to program behaviors, especially with C# for Grasshopper. And that's it.
Good. What about Chao Yu?
Hello, I'm Chao Yu. I'm from China and now I live in Zurich. And now I'm working in block research group in ETH, and I'm working on graphic statics in 2D and 3D. But before I work in grammatical color research, I was doing some using robot to test the acoustic behavior of panels, and I was mainly working on data analysis and visualization.
Good. Have you met Victor Leung?
Yeah, he was my colleague before.
Yeah, he was my classmate here at MIT during my master's. And also Ines Arisa.
Yes.
Yeah, she's a very good friend, so good.
Yeah, she's very nice.
Yeah. Okay, Alois.
Hi, my name is Alois. I'm from France originally, but I'm doing my master's at LTH in Sweden. And I'm currently thinking about what my master thesis is going to be next year. And I'm thinking of doing something that has to do with computer vision and how it can help architects to design. So I'm here to learn a bit more about this, hopefully.
Good. Excellent. Lauren?
Hi, I'm Lauren Dreyer. I am starting my PhD at Princeton with Stefana Parasho, who is also at ETH. And I've been working with, I'm an artist and a fashion designer, but was an architect sort of before that. And I've been working on large deformations and interlaced structures with Sigrid Adriansons at Princeton for the last couple of years. And now working on sort of the robotic assembly side of that, and also interested in like actuating these structures with like soft robotics sort of things, and interested in sensing and that sort of thing.
Good. Let's go for a couple of more, and then tomorrow we will have the rest, okay? So we can move forward. Marina, you'll be, and then Pedro, and then the rest will present themselves tomorrow or later after the break.
Okay, I can go. So I'm Marina. I'm a master's student in Brazil, actually. We're pretty close to Chile a little bit. And mainly, I'm in my final year of my master's, and I'm working between how we can take complex system data, mostly biological data from complex system, and adapt it to architecture and design, but in a more efficiently way and not so mimetical how we are doing right now. And so I'm trying to see how I can take machine learning and deep algorithms to do it. But right now I'm working by hand and doing entropy analysis and general system theory analysis a little bit. And also I'm delivering some classes here about parametric design and digital fabrication as well.
Excellent. And finally, Pedro, and we will move on.
Hi, my name is Pedro Veloso. I'm also from Brazil. I'm a PhD candidate at Carnegie Mellon, so one's my colleague here. In general, I have an interest in space planning, generative design, but my PhD research focuses on multi-agent deep reinforcement learning in architectural design, and a little bit into generative adversarial networks too.
Awesome. Yeah, it's a very interesting group. So I hope that we can, let me share my screen again. The main thing or the main goal is, of course, to learn something, but at the same time have fun. This is like a kind of like a complicated topic. I will explain why, not because it's like we're using machine learning, so it's like super complicated, but it has some, the tools that we will use have some things that we need to comprehend, some things that we need to understand at the beginning. That, can you see my presentation? Yes? Okay, so we will use first like Unity 3D 2020. This is because for a specific reason that I will explain later. We will use Anaconda, that is this package of basically like data science. It basically uses Python, and it allows you to basically also has a package manager. We will use ML agents, and this is like the tricky part of probably what we are going to learn, because ML agent has been around for like more than a couple of years. The version 1, it was released probably like a month ago or a little bit more. And this is probably like the first stable version of ML agents in terms of from version 1, probably things will not change much. By this, I mean that if you, for example, look for tutorials or look for documentation about ML agents on the internet, in YouTube, you will see that most of the tutorials are probably obsolete. And with each version from 0.09, from 0.13, 13, 14, that basically where the distance between versions was like probably like a month or 2 months, a lot of things change. So if you wanted to apply, for example, something that you learned probably from a tutorial or something that you did from the previous version, just to translate or migrate from version, it was like terrible. Luckily now the version is more stable in terms of the core components. We will see how it works. but basically now Unity is using something that is called Barracuda. And Barracuda is the one that is in charge of communicating Unity with TensorFlow. So that gives you a lot of advantages. In the past, for example, for the early versions of ML agents, you had to first build your game, your application, and then train it, and it was like a little bit complicated. Right now, it's easier, but it's still, I mean, the documentation is not very, how can I say? It's difficult to find like resources to get used to the new methods and new functionalities of ML agents. We will do coding in C#. Again, I mean, of course, because given the time, this is not a programming class, it's not a Unity class, but we will try to make things easier so everybody can follow and, again, hopefully learn something. We will do some modeling. I will give you an assignment that I will send you at the end of this session, that you will have to model something for day 3. That I will tell you what to do. If you don't know, if for any reason, if you're not related to like design, architecture, 3D modeling or whatever, I can provide a model, but it will be nice if you can do something on your own. This is, I mean, some people ask me if this is like a project-based workshop. This is optional. If you want to do it, I will really appreciate it. So we can also have this exhibited in the final exhibition that some other workshops are preparing, especially Diana Bogosian. She's preparing all this like virtual exhibition, and hopefully, I don't know, maybe there will be a publication or something. So it will be also like super nice for you to have something to show there. But because this workshop is like mostly experimental, let's see how it goes. Let's play it by ear. So let's see. So the first thing, of course, will be like installing our tools. I asked you in a previous email that I hope you did to install Unity 2020. If you didn't, that's okay. Maybe if you have like 2019 or 18 for this first, I think if you have 2019, it could work. What we are going to do today, we will go through a simple example just to learn and get used to the basic principles and structure of using ML agents. But mostly we will use 2020 because it's super compatible and stable with ML agents 1.0. And also it has some access to some preview packages. I will explain what is that. That are still like experimental, and hopefully they will release soon, especially the robotics part. So these are the instructions in case you didn't see my email, right? You have access for free to Unity Personal. If you're a student and if you have an EDU email, you can get a really nice access package to Unity. You will have Unity Pro that has some advantages for free. You will have access also to like Unity tutorials if you want to learn how to make video games, and other like things like real-time cloud diagnostics and things like that. So it's pretty nice. Also access to team development if you're working with a partner or whatever. If not, the Unity free version will work as well. So in order to do that, I will recommend you to, as I was saying in the email, download Unity Hub. And because Unity Hub allows you to have many versions in parallel of Unity. You can have Unity 2018, 2019, and probably like an alpha version of 2020. And again, I am going through this because the idea, I'm recording currently the workshop, and the idea is that this will be also shared with everybody through a YouTube channel. So it's good that I go through this. And also, some of you asked me which packages or modules should I install for Unity. It's not necessary to install everything. I mean, if you are interested later in probably like compiling, building your application for iOS, which is pretty simple, or Android, or maybe an executable for Mac or Windows or even Linux, of course you install those packages. If not, the only thing that you need to install is Visual Studio Community, which is the IDE that we will use to program. Again, Anaconda is this software package that allows you to basically use data science, and it will be useful for us to get around with some things that we need to do first in the beginning. So for example, creating an environment to install ML agents and other dependencies. For the ones who don't know, basically this is, you can install, for example, Python in your system, but it's always convenient to create like some sort of like virtual environment, let's say like a container, where you will install some specific versions so they don't create like problems with other software that you have installed or clashes with other libraries or things like that. So we can create like a custom virtual environment only for ML agents. And this is really good. I know that some people prefer to do it like directly using, I don't know, like the terminal, the console, but we will do it in Anaconda. We will show both ways. We will do it in Anaconda because it's easier and it's like almost like error-free process. So in order to install Anaconda, you need to go to Get Started and install the Anaconda Individual Edition. Go to Download and select here like the version according to the flavor of your operating system. The only, hopefully 64 bits. And one thing that is mandatory is that you install the Python 3.7 because Python 2.7 was deprecated, so it's not longer supported. And Unity ML agents already move everything to new versions of Python. So now, before we go to full work mode, I want to leave space if you have like any questions, any doubts. I will explain a couple of things after, also regarding the way the workshop is going to work. But if you have any questions, please. Who? Okay, I hope I was pretty clear on that. So we will do this now because while you install this, while you install all the tools, I will explain some base concepts about, for example, from simple things, like a simple explanation about like what is machine learning, what is reinforcement learning, how does it work, for example, the algorithms that Unity ML agents use. And basically this understanding will also make a lot of sense when we go to full coding mode. Before we go into like preparing our virtual environment, I will explain that this workshop will have exercises per day. The workshop, the idea is to have one session per day, 3 hours, from Monday to Friday. But the only problem is, and I want to discuss it with you, on Friday, this workshop overlaps with the class that I'm teaching in Chile. So I will probably send you like a, how is it called? Like a poll, so you can basically vote if you have a specific preference where we can move the last session, that it will be nice to have a final discussion and tips and probably like answer questions. So in relation to that, if you have like any question that is like probably like bigger or more general, or even like more specific to your own interests and projects, and it's something that is not urgent. So for example, like how did you basically like, I don't know, what did you press to do that? That's like an urgent question. But if you want to know more about this, probably it would be good to write it down and I will ask you to send those questions before the last session, so I can basically structure the last session trying to answer those more general questions. And also, like, every session will be divided in two. We will have a 20-minute break in between. And as I was saying, we will have like, today we will start with a really simple exercise that hopefully you will train. You will be training your computers for tomorrow, and we will be basically incrementally adding complexity. So we are ready to, by day 3, when you have ready the assignment that I will send you, start working in hopefully like a final project or in a more advanced implementation. And also that will give me time because as I was saying, my computer died and I just got 5 minutes before the class the spare parts to repair my computer. So it will be nice to do that. So I will stop sharing my presentation and I will I stop sharing my screen. I will share another screen now. Just give me 1 second. Again, if you have any questions, please interrupt me and Unity. Let me share my screen again. And also, I'm sorry if I'm a little bit clumsy with the Zoom because I'm not very used to it. I just had my first Zoom class on Friday. Okay, now I guess you can see my screen. So if we Google Unity ML agents, you will go to, you can find, this is a post from May 12th about the release of Unity agents version 1.0. Yeah, actually here it says that in 2017, the first version of ML agents was released. So the good thing is that, or for the ones who don't know, ML agents is this package that allows you to create environments for training game agents to perform tasks, mostly with reinforcement learning. I will explain what is that, but basically to give automatic autonomous behavior to gaming objects. So let's say if you have a video game and you have like the bad guy you're like playing and you have enemies, for example, those enemies can have or can learn from your behavior to basically try to kill you or something like that. Or if you play in a soccer game, the intelligence of the opposite team, the enemy team, will be controlled by this intelligence model, right? So what they provide is are a lot of these examples where you can do like all sorts of training environments that go from more, let's say like tangible, like I'm quoting, tangible scenarios where you can, for example, have to reach something, to touch it, to also combine that with visual observations, like casting rays onto object, to also add the idea of having like a visual feedback for an agent to learn from the environment. So you have like many examples. So for example, teams playing soccer or agents deciding which way to go, for example, in a hallway, to go to the circle or to the X, or collecting food or balancing. I mean, those examples are like everywhere. And since then, these have been applied mostly because Unity is a gaming engine. It's not particularly like, it was not created for designers, but it's like, or for architects, but it's cool that we can use it. And the advantage is that we can build whatever we do in Unity to any platform that we want. So it has been applied to like video games, to give the intelligence and so on and so forth. So as you can see, they have been introducing a lot of things. That they are now introducing the cloud training, which is like really cool. And I think with the student package, you can have access to do training in the cloud. They are moving forward to something that is really nice. They have a new paradigm of programming that is called DOTS that allows you to train thousands. Basically, it allows you to, with minimum code, you can have like thousands or hundreds of instances of your agents or game objects in Unity, like super fast. So they are adding this also here. And they release also like robotic example that we will use extensively in the last part of this workshop. We will build something based in this. We will heavily modify this because actually the example is not very good, but it uses like really cool things that we can learn. So if we go to the GitHub page where Unity ML Agents is located, you will find like all the documentation, mostly how to install it. And one thing that you can do later, maybe in the break, we will not use it today, is to clone the repository. You can do it by, I can explain it like tomorrow how to use Git if you don't know. Today is not important, but you can even like download the zip file with all the information, and here you will find, basically this is a manual download that you can do. If not, the way you install Unity ML agents is that here where it says releases and documentation, we have now actually release 3. I didn't see that, so I hope nothing changed. Hopefully not. So we'll have a lot of bugs that we will have to solve. You can go where it says click here, right? And you will find the instructions for the installation. So we will go over this, and I will explain. We will go together over the installation instructions, and then I will go into like the more theoretical part. So if you go to installation, you will see that you need first the Unity ML Agents package. And the way you install it, that is really easy now. Let me see. You first need to open Unity Hub. And the best way, if you go to installs here, you can see, for example, I have 6 versions of Unity currently living in my laptop because I work in some projects that use like old versions of Unity. For this, I have to install other versions that are newer. I have a beta, alpha versions, and so on and so forth. So did everybody have the chance to install Unity? Yes?
Yeah.
Okay, so if you go to Unity Hub, make sure that you have at least one version of 2020. Hopefully the one that I recommended, that I think it was B13. If you have B12, also works, so don't worry. And if you go to projects, if you have one of those versions installed, if you go to projects, you want to create a new project, right? You go and you click where it says new, and it will ask you what you want to do. You have like several templates, 2D for 2D games, 3D with extras that I have. It adds access to some preview packages, or the high definition render pipeline that basically you can create like high-end graphics. The lightweight render pipeline where you can basically do really advanced stuff for mobile devices, or something that is like pre-tailored to do VR. In this case, we will just use the 3D, and we can call this whatever you want. I will put session 01 DF workshop. And you need to give it a destination. I will save this in a new folder. The way it works, of what I'm doing, it doesn't matter if you're using Windows, Mac, or Linux. It's basically the same. So that's also an advantage. So let me create this. I'll put here session, sessions. And I will create this. I will select the folder. And once you select the folder, the name, you just hit create. And it will take a while to prepare all the environment. It depends on how fast is your computer. Usually just to do what we're going to do, you don't need much processing power. In my case, if you see that my computer today is going slow, it's because I'm at the same time with Zoom that many things open and the computer suffers a little bit. Hopefully tomorrow or Wednesday will be not as bad. So you can see that it's importing first the assets. If you have worked with Unity, I will explain a little bit now how it works and the basic concepts that will help us to create or do what we want to do. I mean, we could spend like a month talking about Unity functionalities, but I will try to briefly go to the main features and explain some things that are important. So basically it's compiling these assets that is important, and let's wait for that. Again, any questions? No? Am I going
Yeah,
to?
I have a question.
Okay.
Which one did you click on, 3D or 3D? But I didn't have a 3D with extras option or.
Just the 3D, the normal. Do you have like any? 3D?
Okay.
Yeah, the 3D normal. We don't want like any special thing.
Okay, thanks.
So, you're welcome. So if you.
Sorry for interrupting you. I have another question also. So you mentioned that you've been working on release number 2, and I think the link that you clicked on was for the release number 3. And since I was following this like ML agents, and I realized that there might be some like drastic changes in the configuration files and other stuff. Is this going to make any difference if you have release 2 or 3?
I don't know, because I just realized that we're using 3. So, I mean, I will give it a shot going with 3.
Okay. I think that's 2018 for 3.
No, we're talking about ML agents. So, I mean, I did this on purpose. So if you realize that by default, when I opened the project, I opened it in 2018, right? So if this happens to you, don't panic. If you have like an older version of Unity installed in your system, you can just close it. This was on purpose. You can close it. No, I didn't do anything. Go back to Unity Hub, and you can see here when you created the project, you have the option to select which version of Unity do you want to use. And this is very important because this is like very Autodesk type of thing. Usually you go from an old version to a newer version. If you open a project that was built, for example, in 2017, and you open it in 18, probably you will have like some minor problems. But if you try to open a 2019 project in 2017, probably everything will break. It will open, but nothing. I mean, if you're using just like specific things, the project might be unusable. So it's not as severe as Autodesk, you know, that you can go like backwards in files, for example, in Revit or 3D Max or whatever. But just so you know, I mean, this will happen. Actually, I will choose 2020 B13, and you can also choose the building platform. For us, it's not important right now. So I will click here, and Unity will ask you, I mean, do you want to upgrade your project to a newer version? Because some things will change, especially the manifest that handle packages and things like that. So I will say yes. And because I'm moving to a newer version, I won't have any problem because I didn't produce any files or I didn't do anything inside. So Again, first thing first. It's verifying, probably will take a while. In the meantime, if you install Anaconda, I will do that so we don't lose time. If you just open Unity with 2020, and we will catch later with that. Sorry, my email is again going crazy. Close the email. Oof. My computer is going really nuts. Okay. If you open Anaconda Navigator, we will do like terminal stuff tomorrow, but right now let's do with this UI while it's opening Unity and preparing everything. It takes a while to load, but it's really easy to set up this virtual environment. And the way you do it, when you open Anaconda, you will find this. And you will find that you have a Jupyter notebook that basically is like a web-based editor where you can write Python files. You have a Spider to do scientific development and other things to do things in R. We don't care about that. The only thing that we care right now is that you will see this navigator and you will find this option here that is called environments. And if you see here, probably you will not have any environment, maybe the base environment. And as you can see here, I have like many according to, I don't know, like ML agents versions for use with different sensors, to use PyTorch, for example, to use PyTorch with CUDA, to use also PyBullet, for example, or PyDrake to control robots or things like that. So this is the advantage of have like custom containers with different dependencies that you can use according to what you want. So the way that you create, the easy way that we're going to see today, you can go to create and you press on create and you need to give this a name, right? And you need to make sure that the Python version is hopefully 3.7 or 3.8, both work. Let's go with 3.7 and you need to name this. You need to give it a name. So in this case, I will say df workshop _ workshop. Hopefully you don't leave spaces between words because it can give you, of course, like empty spaces can give you problems. So if you give a name, hopefully a short name, and you will understand why, you are okay. So when you do this, you hit create, and Anaconda will start installing and creating this. We'll install Python. It will install, I think it's installed by default NumPy, but it doesn't matter. I mean, we don't have to worry about that. It will install like the minimum things that we need in order to install also ML agents. Any questions about this? I know that some of you have already experience in this, so if this is boring, please, excuse me. We will go to more interesting stuff soon.
I have one quick question.
Okay.
Do any of the names that we create for in Anaconda or anything like that, do they need to follow C# conventions in terms of like camel case or anything like that? Or are we okay just kind of naming it in whichever way we want?
No, because basically we will, I mean, to be honest, we will not touch Python.
Oh, okay.
So this basically, I mean, we will use it, but hopefully I don't think that we will, probably there is one part we will have to go and edit something. But since we are not doing that, maybe. Don't worry about that. So basically, we will work specifically with C# inside Unity, and all the Python part will be managed by TensorFlow and this thing that is called Barracuda. That is the one that makes the dirty job for us. So we will worry about only C#.
Okay.
So as you can see here, I have this environment called DF workshop. And if you press the play button once, it will give you two options. One is to open with Python. We don't want that. And the other one is open the terminal, right? You need to basically choose open terminal. And this will open something similar to this, right? This is like the typical like command line. In this case is, I don't know if you can see it well. Let me change the way it looks because I have it like with fancy colors. It's okay, it doesn't matter. So basically what you will see here is, can I, yeah, Control plus. So this is my terminal. Probably you will see it as a black with black background with white letters. You can personalize this. This is just like stupid things that I do. So this will give you something similar to this, right? On Windows, it would look similar. In Windows, it's a little bit more complicated, but the good thing about Anaconda is it just prepares everything for you in terms of preparing the command line, so you can just execute the commands. In Unix-based systems, it's like easier because basically you do a lot of things with the terminal. But as you can see here, it has between parentheses the name of that we just gave to the environment. So basically this means that everything we do now here, everything we install, it will remain in this environment. So for example, if I want to close this environment, I can just close the terminal window or just say like conda deactivate. And you see that how it changed here. It says base again. If you don't remember or if you don't know how to activate it again, you can just do the procedure of going to Anaconda Navigator, pressing play, open terminal, or also you have like some, I can send you documentation about this. You can say conda env list, and this will show you the list of environments that you have. So you can do conda activate df workshop, and it's case sensitive, so be careful with that. So you can see that now my environment is activated again. So if you see something like this, you are golden, you're okay, you're ready to basically move to the next step. And I think we're doing okay in time. So sorry if I'm slow with this, but this is very important. So some people are not left behind with instructions. So basically it tells you that you have like also like some packages. And one thing that we will do before going with Anaconda, we will leave the terminal open. We will go back to Unity, and you will see first how to install or how to use ML agents inside Unity. For the ones who don't know, Unity is this, or maybe you saw a video if you have never used it. This is like the default view of Unity. I always work like this. And here you have something that is called assets in the lower left part of the screen, where basically you have all the files that are in your folder project. So we will import some things inside this folder. And the good thing is that if you, for example, right click in assets, and if you go to reveal in Finder or in Explorer, you will see that you have access to the main project folder, and you will find the assets folder here, right? And here we will create like a folder structure later when we start working, and importing files and creating files and moving files and so on and so forth. Everything that you see here in hierarchy are the objects or the things that you are creating specifically for one scene. And some people always ask me like, what is a scene? And this case, basically, and scene is like a video game stage. So if you're playing Mario Bros, for example, Super Mario Brothers, you have one stage that is Mario Brothers in the world of candy, and the other one is other scene could be like Mario swimming in under the sea. So basically, this is like the equivalent. So you can have things set up here, and you can have another scene with total different elements. And the things that you create for a specific scene you will see it here. So right now, by default, we have always a camera where if you click the camera, it will show you a preview of this ugly horizon with this sky that I hate. And also you have like a light, like a default light that it's a sun. And you can start adding more geometry. Here in the inspector, and this is important, you have basically all the properties of game objects. And also this is very important for the ones who have never used Unity. In Unity, we will learn that everything is a game object, right? That is the most basic type of entity that lives in Unity. And for example, if I go here to hierarchy and I right click and I said create empty, I am creating this game object, and you will see that it has a name, it has like some things, and it has something that is called a transform. Basically, the transform is something that indicates like the basic parameters in terms of position, rotation, and scale. And we will use this heavily. And for example, if we compare what we're seeing here in the inspector, when I select the empty game object, it only shows you that. But if I go to directional light, you will see that it has a transform component, but also it has a light component. So basically, like this is a game object that has another like interface or component added to it that allows it to act as a light. So if I select, for example, this, that is the main camera, it was also at some point an empty game object that received like a camera component and an audio listener that allows it to behave like a camera. So this is very important because we will work with this a lot. You have also here some tabs. This is the scene where you can basically switch between perspective and isometric view. We will see that. You have the game preview window. You have the asset store, and this is the one that I wanted to show you now, is the package manager. So in the past, you had to do all the installation of ML agents through this like really cumbersome, like awkward way, like with command lines, and sometimes it didn't work and blah, blah, blah. But now, since like a couple of versions ago, you can install packages here. So you can find like really cool things that will make your life easier inside Unity. So in this case, by default, if you go to this button here where it says packages in project, it shows you what are the packages that Unity installs for you by default, right? If I switch to all, you will see that this list grows. And here in advanced, next to advanced, you can write ML agents. If you do that, ML agents here in this part, you will see that it will show you ML agents, Unity Technologies version 1.02, released like today is 21 to 3 weeks ago. So actually that's good. So that is pretty good. And it says like use state-of-the-art machine learning to create intelligent character behaviors in any Unity environment, games, robotics, film, etc. It's good that now they are actually open and saying explicitly that this is Unity is not only for games, so you can do like even more advanced stuff. So it shows you the version available. So you can here just press install in this button that where my mouse pointer is. So if you press install, this will start downloading and compiling all the packages so we can use them in our project. So you see it's like connecting to the Unity servers, is downloading like math scripts, like C# scripts that allows us to do like mathematical operations, probably like the matrix operations, and basically the basic files. It also installs Barracuda, that is, again, the system that allows you to communicate seamlessly with TensorFlow to do the stuff. So that will take, again, like a couple of, like some seconds or probably like 2 minutes, and it will import everything. Any questions?
Question here.
Okay.
We need to at some point, I'm not sure if I missed that part, like we have an Anaconda environment and now we have ML agents. And after some point, we need to install things in our Anaconda environment to match this ML agents version, right?
Yeah, we will do it. Yeah, like the next step is to do.
Okay, so it didn't happen.
No, it didn't happen yet. So what I'm doing, I'm jumping from one side to the other because, I mean, to install things takes a while. So in order to keep like everything like more fluid, while we install the Anaconda, I was opening Unity, and hopefully you were doing the same. And now that we have ML agents, you see now it says install, and sometimes it will give you the option to update your ML agents or packages that you're using. Now we can move to install in our system, in our virtual environment, all the Python part of Anaconda. You know if this was installed, of course, if it says like up to date and it didn't give you any error here in the console, this tab that you have here, right? It's not showing me like any error, so that's okay. And here in project, where we have the assets folder, let me put this bigger, you will see that you have like packages like for making 2D sprites. You will find a package that is called Barracuda. That is the one that I was talking to you about. And also you will find a package here that is ML agents. So in terms of like Unity, we are good to go to start doing stuff. Now we need to take care of the final step to have everything ready to start working. That is the to install ML agents in our system. So basically that happens outside Unity. Everybody okay? Everybody got the chance to install this without a problem? Yes? If not, let me know. We will have a break soon, so don't worry. And we can also have like some troubleshooting during that. So I will minimize Unity, and if I go back, that's what I hate. If I go back to, was I using this? Yes. Here, for example, it tells you that in the documentation, in the installation, you can download the repository of ML agents manually, or you can clone the GitHub if you write this in your terminal. But what we want to do is write this line that is here. How can I, let me see, how can I zoom in so you can see it better? Zoom. It doesn't matter. So
we can see it.
You can see it? Okay, good.
Yeah.
So basically you just need to use pip, that is this package manager for Python. And if you go to your terminal, remember, you need to have the environment activated. You need to write pip3 install, and then here as it says, ML agents. Install ML agents. And this will start installing all the dependencies and all the files necessary to work with ML agents. So as you can see here, it's installing a couple of things to manage the gRPC objects, also TensorFlow. And it's a little bit slow, but hopefully it will install. I mean, it's a little bit big. So if you manage to do this, it's installing also Pillow for images and a lot of things that probably you don't need to understand. It depends on the speed of your internet connection. It will go like fast or not. Here, at least this is working fast. So you see it's also installing NumPy, TensorBoard, it installed Keras preprocessing, something that is called Google Pasta that I don't remember what it uses, SciPy, that is all this functionality for science data management, and so on and so forth. So you should basically be okay if you're seeing this, and if at the end of the process it doesn't give you like any error, if you don't have like any mistake, you're good to go. So I hope if you have a problem, please say it. No? Everything going okay? Smooth? Okay.
So far, so good.
Yeah, I will upload this class as soon as I finish this, so you can go over again after. So don't worry. Okay. So while you do that, I will continue with the presentation, so we will see and we will understand first how this world of the ML agents work, or basically why is it so, I mean, it sounds like complicated what we're doing, but actually when you understand it, it will make a lot of sense what we're going to do. And I think the major, like the main barrier or the main obstacle that we have as designers. So for example, for me, always has been like the way, for example, you approach to this like advanced topics. So in my case, for example, taking computer science here at CSAIL, the Computer Science and Artificial Intelligence laboratory at MIT, you go to classes that are like super advanced, and they basically bomb you with all this math and nomenclature, and usually things that they like the professor, because of course they are like teaching undergrads or grad students that have been trained or hardwired to understand these things. It creates like a huge obstacle for me. I suffer a lot. Trust me, because the last time I had a calculus class was in 2004. So 16 years ago. I'm 39 now, almost 39. So imagine like to see like derivatives or integrals or like super long equation has been like really tough, especially since 2 years ago, since I returned from my PhD. So what I will try to do here, because I am not a computer scientist, I don't want to be a computer scientist, I am a designer that like to play with these toys. I will explain you in a basically like simple language what is going on. And I think that will be, I hope that you appreciate that, because again, this is like the most difficult part of the things. So I hope you are still seeing my screen. I will do half of the presentation. We will take a break, and then we will see the final part of the presentation, and we will program our first agent. So that is like pretty exciting. The problem with this is that I don't see my notes. Again, I had to use Google Slides for this because my other computer died. So I hope, okay, now I can see my notes. Okay, so you see the presentation, right? Yes?
Yeah.
Okay. So we will learn a little bit about what, why, and how things are going to happen and in this path of using machine learning for this. And everything will start from just like a very simple question, like one of the most fundamental questions for scientists, for example, like neuroscientists, or even now like computer scientists that are dedicated, that have been dedicated to understand human mind is around, I don't know, like since like many decades, is how humans or living things learn a new skill. So there is a desire to understand basically something that it looks like obvious, but if you start thinking about it, it's something that is like pretty complex. So if we can understand this, we can basically, if we actually understand this, we can enable, for example, like human species to do things we might not have thought before. And also, if we have the ability of understanding really well how living things learn new skills, we also have, we could have also the ability to train machines to do more human tasks and create true artificial intelligence. Even though that if you're interested in the subject and you read about it, probably like most of the most famous artificial intelligence scientists, they tell you that it will be like another 30 years until we reach like a general artificial intelligence that basically is like humans. Right now we have all these things that we are super excited about and also sometimes afraid, but I think we have still a long path to have like a general artificial intelligence. So while we don't have a complete answer to the above question like yet, like how do we learn like skills, like humans especially learn like new skills, there are a few things which are pretty much clear that irrespective to skills, we first learn by one thing, interacting with the environment. And probably this is like also which makes these sessions that we're having here different from the rest. Because if you see that most of the other workshops that are happening related to artificial intelligence, they are mostly based in image treatment. And in my case, because I care and my research has to do a lot with gestures and tangible stuff. And I basically, I like a lot like anthropological theories about how human intelligence was developed mostly as opposite, like many old anthropologists said that it was because of vision. Some new anthropologists or new theories say that basically our intelligence was developed mainly by touch, right? And that is something super interesting for me. And basically now, like the answer probably to that question is that we first learn by interacting with the environment. Whether we are learning to drive a car, for example, or a child learning to walk, the learning is always based on the interaction with it's around us. So learning from interaction is the foundational underlying concept for all theories of learning and intelligence. So first thing first, like what is artificial intelligence? In short, AI is any computer program that does something smart. That is like a very, very simple explanation, right? And artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages, for example. But the question is like, something is smart. What is smart? And if we Google, for example, what is smart, I think like the first and especially the second definitions that Google gives us are sufficient enough or are good enough to basically understand. That it says like having or showing a quick-witted intelligence, or a device, for example, programmed so as to be capable of some independent action. So that definition for what smart is like pretty good for what we want to do. Basically to give some independence to some agent. Basically artificial intelligence mimic cognitive functions that are associated with human minds, such as learning and problem solving. And basically we can do like many things. I mean, if you look for applications about like artificial intelligence, like specific applications, you can find like some related to travel, for example, to drive, to fly a drone, or in science and medicine, to discover new uses for existing drugs, or spot cancer in tissues, or identify diabetes, retinopathy, or an analysis of DNA, or in agriculture to detect crop disease, or spray pesticides with pinpoint accuracy, or security, or finance, or assistance, or programming, or even creativity, writing music, designing logos, come up with new recipes. We see like every day that new things are emerging more and more. And especially now, the interest for designers or architects or people that are into robotics, it's a proof of that. Probably you have heard of Runway ML. Have you heard of this tool? This was programmed by a former student of mine in Chile, Cristobal Valenzuela. He's a colleague, a really good friend. And he got interested in machine learning, and he said like, oh, I want to just give designers the possibility to use this, or artists to use machine learning to do cool stuff. And they are like doing pretty well. He has like this company that is growing because it's being adopted by many, many people. So that was what is artificial intelligence. But when we ask what is machine learning, sometimes, and this is also important, we tend to confuse these two things. Basically, machine learning is a subset of AI. So basically, that is that all machine learning counts as an AI, artificial intelligence, but not all AI counts as a machine learning. And that is like pretty interesting, because sometimes you get confused. And I mean, there is this famous meme that says that if it's for a project, it's machine learning. If it's for a grant, it's AI. So basically, it's that tells you a little bit what's going on. So basically, machine learning is an application of artificial intelligence that provides systems with the ability to automatically learn and to improve experience without being explicitly programmed. And that is also like pretty important, and like the main thing that we're doing here. Machine learning focuses on the development of computer programs that can, for example, access data and use it to learn for themselves. And the process of learning begins with observations of data, such as examples, direct experience, or instruction, in order to look for patterns of data and make better decisions in the future based on this example provided, right? So what I'm trying to say here is that machine learning is highly dependent on data, right, of any type, like vectors, pixels, and so on and so forth. So the primary aim is to allow the computers to learn automatically without human intervention or assistance, and adjust the decisions accordingly. And another question, what is deep learning, right? We now are listening to deep learning. When I did my first, my master thesis at MIT, I was using machine learning, and deep learning was something that was not very popular. Even machine learning, I didn't have like TensorFlow yet. It was like just coming out, or PyTorch. So these are kind of like new concepts. So deep learning is a subfield or subset of machine learning, and is concerned with algorithms inspired by the structure and function of the brain, called artificial neural networks, the famous like ANN. So basically deep learning architectures such as deep neural network, deep belief networks, recurrent neural networks, or convolutional neural networks have been applied to many fields that include computer vision, machine vision, speech recognition, natural language processing, audio recognition, social network filtering, machine translation, and so on and so forth, where they have produced results comparable to, and in some cases, even like surpassing human expert performance. So basically like a difference, we'll say, it's like deep neural nets are like basically these huge neural nets or models that have like many hidden layers that are like huge, that can perform more complicated tasks. And if we look at the types of machine learning, this is something that is not obvious, but is something that is, you can find it out there. You have like different types. Probably there are more, but the main three types are this. You have supervised machine learning, you have unsupervised, and also you have reinforcement learning. Easily explained, for example, supervised learning is task-driven. And usually you have the most simple types of supervised learning in terms of regression or classification. For example, object detectors. When you detect, for example, a cat in a picture, or you can differentiate a cat from a dog, or you have regression where you can basically associate this with a continuous value. For example, a pose. There is like a very famous tutorial from Daniel Schiffman using this really nice library NL5, it builds on top of TensorFlow.js, where you can, for example, use regression to predict poses and assign continuous values to this. Or you can train a neural network to predict that if I'm holding a bottle or not, and so on and so forth. So basically, these are like always task-driven. On the other hand, you have unsupervised machine learning, which is very data-driven. And basically, when you don't have a goal in mind, but you have a bunch of data that somehow you want to analyze and you want to find a pattern, a hidden pattern, basically you can use, or you use unsupervised learning. So you have like many techniques. So like PCA, principal component analysis, or you have TINSI, where you can do TISNI, sorry. TINSI is the microcontroller, TISNI. For example, with PCA, you can do dimensionality reduction to understand like how data sets with a high number of dimensions can be understand in like, for example, like parallel graphs and so on and so forth. So for example, this is heavily used for urban data scientists and urban designers that understand like phenomena, or like, I don't know, whatever. I mean, there's a lot of applications of that. And on the other hand, we have reinforcement learning. That is basically what I was saying, algorithms that can react in a simulated environment or learn from that interaction with the environment. So the definition of reinforcement learning it could be, or like the simple definition is a goal-oriented learning system based on the interaction with the environment. And while most of the applications of machine learning we see and use every day are based on vision, reinforcement learning is said to be the hope of true artificial intelligence. And I think it's rightly said so, because the potential that reinforcement learning possesses is immense. When people talk about basically like general purpose AI. This is why if we see, for example, why, for example, reinforcement learning is one of the fields in artificial intelligence that is growing like faster or rapidly. I mean, it's like pretty obvious. For example, right now, if you see what's going on in the, let's say, like computer vision type of machine learning, you see that algorithms that, I don't know, like object detection, for example, like the first version of YOLO, that is you only look once, like this one-shot detectors. It was like super fast. Now we have YOLO versus 5, that is faster. Or we have like, I don't know, like RNN detectors, and now we have like super RNN detectors. So you see that most of the new things are like pretty little. You just see like improved versions of what came out years later. So we had generative adversarial networks. Now we have DC GANs, a style GAN, or like whatever GAN. So, but now, for example, in reinforcement learning, because the applications in especially robotics or systems that actually interact with the environment, we see like a lot of advancement. We will see, for example, Q-learning. In Q-learning was like the algorithm to perform reinforcement learning. And today we're seeing like super advanced stuff like SAC, the soft actor critic, things that can learn like faster or take more data or can be combined with vision algorithms. So the main advances, I will say, in my opinion, because I also talked to a professor here, are being or are happening in the field of reinforcement learning, where they are producing wide variety of learning algorithms for different applications. So it is important to be familiar with these techniques. You can see, for example, the Atlas robot from Boston Dynamics. And you can see the huge advancement also in the dog that they just started selling, the Boston Dynamics. The advancement in self-driving cars that are getting better and better, but still they are facing like other issues that probably are not really easy to solve, like the self-driving cars. But we're seeing like pretty good advancements. So if we start with an analogy, for example, if you had, for example, a pet in your home, at your house, you might have used the typical like technique with this pet, a clicker or a whistle, which is a technique to let you know some, to let your pet know some treat. So basically he knows that it's about to be served, right? So you click and your pet can start like drooling and knows that you will give him a reward, a treat. And you can use the technique to reinforce your pet to practice good behavior. For example, don't bark, or sit when you show your hand, or give you the hand, right? Or I don't know, turn around or jump or whatever. So you click the clicker and follow up with the treat to basically reinforce that good behavior. And with time, your pet, of course, gets accustomed to the sound and respond every time he or she hears the sound. And with this technique, you can train a pet to do good deeds when required, right? Now, if we make this, so basically, if we try to translate this into a reinforcement learning problem, we can see that the pet becomes the artificial intelligence agent. The treat becomes something that is called the reward function. And the good behavior is the action that results from this reward function. And everything, basically the environment, is what is surrounding this idea. It could be the park and so on and so forth. So basically it's like really easy to understand in these terms what a reinforcement learning algorithm is, right? So basically, yeah, that example explains like what reinforcement learning is, and this could explain a little bit more in detail how reinforcement learning looks like. This is actually a classic example of reinforcement learning. And if you want to apply this to an artificial agent, you have a kind of feedback loop to reinforce this agent. It rewards or get rewards when the actions performed are right, and it receives punishment if, in the case, these actions are the wrong ones. So basically you have what you have in your system, and this is explained in this diagram. You have first something that is called an internal state, which is maintained by the agent to learn about the environment. So basically it's like some sort of like memory or like general perspective about what is going on that will give him the possibility of acting in this environment. You have, again, this reward function. In this case, is the cheese. In this case, if our agent is the rat, right? Which is used to train your agent how to behave. You have the environment, which is used to train your agent, which is the scenario the agent has to face. In this case, it could be like a maze. And you have an action, which is done by the agent in the environment. So basically the action will be like moving in a direction, walking in a certain direction to solve the maze, basically to find the exit. And last but not least, you have this agent that does all the deeds, right? So if you can see like the diagram, the graph here, you have an agent that basically performs an action, and for that action, it could receive a positive or negative reward. And basically based on the observations and some parameters like learning rate, inverse temperature, discount rate, or whatever, it starts basically modifying this internal state that will allow him to decide which is the best next action that could perform, right? Based on the reward. If you do something that it was not, you took like the wrong action, basically that will modify which state and which action you will take next. So when you start like doing hands-on reinforcement learning, you start asking yourself like what to do and how to map these situations to actions. Basically that's what you learn, how I can map a situation to an action. And the end result basically, or the end goal, is to maximize the numerical reward signal, right? The learner, in this case the agent, is not told which action to take, but instead it must discover which action will yield the maximum reward. So basically that is like the what's going on. Basically the agent doesn't have like any pre-programmed like instruction. It just have the ability to do something, for example, to move forward, to jump, to whatever. And it will start adjusting with which set of actions, the policy it will apply in order to just maximize the reward, to get more and more positive rewards. So let's try to understand this with again, this simple example. So if we try to understand, for example, how a child will take, the steps that a child will take while learning to walk, right? The first thing the child will observe is to notice how others walk, right? This is an observation. You will see the parents or like relatives how to walk, or that they walk around him, and he will start, or she will start like, oh, basically they're doing something, and it will start with understanding the environment. And also, basically, you will use your two legs, taking a step at a time in order to walk, grasping this concept. The child tries to replicate. So there are also like types of, hopefully we'll have the time to see this. I will leave this to the last part of the workshop, how to use imitation learning. But basically also you can say that soon he or she, the baby, right, will understand that before walking, that he needs to, or he or she needs to stand up, right? This is a challenge that comes along with while trying to walk. First, before walking. You need to learn how to stand up or to crawl, right? So now that the child's attempt to get up, staggering and sleeping, but still determined to get up. And then there's another challenge to cope up with. Standing up, for example, could be like an easy task to keep your balance or whatever. But now to remain still is like another task before walking. So you learn to get up, then you need to basically stand still. And basically after you do that, the real tasks come where basically you need to start walking. But it's easy to say than actually do it, basically. And here, basically, the child or you that are analyzing this, that need to basically keep many things in mind. So again, like you're just not walking now, but you're also doing all the tasks that you learned to do before, like getting up, balancing the body weight, deciding which food to put next and where to put it. So you're getting constant feedback also from your environment. And you're also, because you're doing something, you're getting, right, a feedback about what this is producing. So sounds like a difficult task, right? And it actually is a bit challenging to get up and start walking, but you have become so used to it that you are not faced by the task anymore. Now you can get basically a gist of how difficult it is for a child to start walking. So if we put this in a simple diagram, we can say, or we can extrapolate this or formalize it as a problem statement. So basically we can say that the child, in this case, is the agent trying to manipulate the environment, which is the surface on which the baby walks, by taking actions, basically like walking. And she tries to go from one state, like each step she takes, to another, right? A step will be like step 1, to the other like stage will be like step 2, and so on and so forth. So the child gets a reward for this. In this case, the love of the mother or the father, when she accomplishes a submodel of the task, and will not receive this love or a chocolate or a cookie or whatever when she is not able to walk. So basically this is really simplified explanation, but I guess, I mean, you can understand from this example how everything works, right? And basically what are the components of a reinforcement learning problem that is based on this agent that performs an action in an environment, and it gets a reward that defines a state to take the next action. So the simple explanation for this, or the mathematical framework for defining a solution, and after this we will take a break of 15 to 20 minutes, so like a bathroom break, coffee break, whatever. The mathematical framework for defining a solution in reinforcement learning scenario is called a Markov decision process. Right? Probably you have heard about this, and this can be designed as a set of states, S, a set of actions, A reward function, R, a policy, pi, and a value, V. So basically what had happened is that we have to take an action A to transition from our state to our end state S. And in return, we get rewards R for each action we take. This could be either positive or negative. And our actions can lead to a positive reward or a negative reward, as I was saying. So the set of actions we took define our policy. And the rewards we get in return defines our value, from the value function. And our task here is to maximize our rewards by choosing the correct policy. So we have to maximize basically this function for all possible values of S at a time, T. So, sorry, this is the last one before we go to a break. And this is a representation, for example, of a shortest path problem. Probably if you have a study like graphs or like algorithms like depth first search, breadth first search, A*, whatever, you have seen like example like this, how to navigate the graph. And basically the task here is to go from a place A to a place F, basically the node A to the node F. And each of these edges of the graph, these lines, have a cost. So basically you can say that to go from A to E, it will cost you 20. If you go from A to D, it will cost you minus 20, right? So the negative costs are actually some earnings on the way. As the opposite, basically those are, the positive values are cost. So we define values, the total cumulative reward when you do a policy. So here, right, the set of states are the nodes, right? A, B, C, D, E, and F. The action to take is to go from one place to the other, A to B, C to D, and so on. The reward function is the value represented by an edge, the cost, right? Positive or negative. And the policy, in this case, is the way to complete the task, going from A to C, and then to F, for example. So now, let's suppose that you are at place A, right? The only visible path is your next destination, and anything beyond that is known is not known at this stage. So basically, you have an observable space. In this case, if you are an A, your only observable space could be go to B, C, or E. You don't know, or D, sorry, you don't know F yet because you have a direct connection. So in this case, for example, you can take a greedy approach and take the best possible next step, which will be going from A to D, right? Because A to D, it will give you 20, right? As opposed to lose 20, lose 15, or lose 30. So basically you go to with the best option that is minus 20. And from this subset of B, C, D, or E possibilities. And similarly, now if you're at D, right, we see that going from D to F has the lowest cost, and hence we take that path. So basically your policy will be going from A to D and D to F, and that will be like the greedy approach, like the most optimal in terms of cost. This will give us a value of minus 120. So this is amazing. Now we just implemented, like in theory, a reinforcement learning algorithm. And basically this is like known as the epsilon greedy, which is literally like, again, like a greedy approach to solving the problem. Now, if you are the agent and want to go from A to F, again, you will always choose the same policy. Basically, if you are doing this approach based on cost. But are there any other ways to travel this graph? So that is a good question in this case. So basically, we can ask if this category of this greedy approach is like pure exploration or pure exploitation, right? And notice that the policy we took is not an optimal policy. We will have to explore a little bit to find an optimal approach, because this was only based on cost. We just went to minus 20, minus 100, and that was it. But probably there is another way, another path that has some other characteristic that could make this even like more optimal. So the approach we took here is policy-based learning, and our task is to find the optimal policy among all the possible policies. And there are different ways of doing this. So we can have, for example, a policy-based approach where our focus is to find the optimal policy. A value-based, the one that we took, that is where our focus is to find the optimal value, like a cumulative reward. Or the action-based, basically where our focus is on what optimal actions to take at each step. And basically reinforcement learning, I mean, this policy approach is the one that we will take with machine learning. So now that are 5 to 4, we will take a small break. Sorry if this was like extensive. I know they could be like really, I tried to make it as simple as possible to explain. If you have any questions, please, if you have it, write it down. You can say it after the break. We will return in 20 minutes. That is, let's say like 4:15, right? And we will continue with this. So this will give us time to have a coffee, smoke, or go to the restroom or whatever. Okay. Do you have any questions now? Am I being too boring? No?
Diego, would you mind introducing yourself as well? I think I missed if you did, just your background and everything.
Introducing myself?
Yeah.
Oh, I will go really fast to the first slide. So basically I am, I am Diego. I'm from Chile. I am a PhD student at the Design and Computation Group. I studied architecture, a master in architecture in Chile. Then I got my master's degree in my second master's degree at MIT. Then I returned to Chile. I've been teaching for 11 years. I don't practice as an architect anymore. I just practice as a design consultant, and I don't have my practice anymore. I've done like a lot of projects related to design and machine learning. And now I am at least for 3 more years here at MIT to hopefully get my PhD degree. It's a 5-year PhD degree, so it's a long time. I will be 42 by the time I'm done with this, so that's a little bit discouraging, but that's okay. That's a brief introduction. I can give you more details later. Okay, so I will take more time. Yeah. Now that it's 4:20. We will return and we will, I will give you the 5 last slides and we will program something really cool, okay?
Yeah, yeah.
Okay, see you in 20 minutes.